In this lecture, I am going to explain you about 4 topics. One is the simple linear regression. The second, the uses of linear regression. Third one is the regression equation. And the final topic is assumptions of regression equation. When we talk about a regression equation or regression is a statistical model which helps you to estimate the relationships between variables. In other words, regression equation or regression models are used to predict or forecast the outcome variables. And regression is a statistical tool which is most predominantly used in data analysis, and it is also used to predict the outcomes. Now, next is we'll discuss about what are the uses of regression equation or regression model. So when you're evaluating a regression model or using a regression model, we can use it in different areas. Like if you want to estimate the sales based on your advertisement spend, you can use a regression model. You can fit the data on a regression. Next is in a pharmaceutical sciences, if you want to know the effect of the drug on patients, in such case also you can use the regression equation. Then in a regression we have a different types of regressions. We can say that as the simple regression or simple linear regression, then multiple regression. So here we talk about the simple linear regression. In case of a simple linear regression, you will have only 2 variables. You will need to find out the relationship between 2 variables and how one variable is affecting or impacting the second variable. So the regression equation is written as y equals to a plus bx. Here in a simple linear regression, there will be only 2 variables. One is the independent variable and the second one is the dependent variable. The independent variable is denoted with alphabet x, whereas the dependent variable is denoted with the alphabet y. So based on the change in the x variable, we will try to predict the y variable, that is the dependent variable. So in a regression equation, as we said, y, the dependent variable, is equals to alpha plus bx. Here a stands for the constant or an intercept, whereas b stands for the slope. So the slope of a line in a regression equation explains you what percentage of change will happen in a dependent variable when you change your independent variable. So the beta value or the b ranges with different values. If b is 0, then we say that there is no relationship. And if it is positive and higher, we can say that independent variable has got more influence on the dependent variable. Next, coming to the assumptions of simple linear regression, we have certain assumptions to be met. The first is one of the assumptions, or the first assumption of simple linear regression is that both the independent and the dependent variables should be measured on a continuous scale. That is either on interval scale or the ratio scale. This is one assumption. Second is, in case of linear regression, there should not be any outliers. An outlier is a data point which is strongly or highly deviated from normal observations. For example, if an income of a household or income of an area, the mean income of area is let us say $100,000, then outlier is where it is $1,000,000. So you have outliers or extreme values which are away from normal data. This is another assumption. Then when you are running a linear regression analysis, normality of residuals should be there. A residual is the difference between your observed variable and the linear estimation. So the residual values should be normally distributed in case of, or this is one of the assumptions of linear regression equation. So based on these assumptions, and we need to run the regression equation. So regression equation in simple will be used in a statistical analysis, especially in a stock prices, evaluation of stock prices, or finding out a relationship between different variables. Then in case if any of the assumptions of a linear regression model or a straight line fit is not met, then you need to find out various other alternatives like non-linear regression models or multinomial models, or if those models are not possible, then you can also try with transforming the data. So you can use various transforming techniques like log linear transforming or any other data transformation tools can be used to transform the data, and if then the residuals are considered as normally distributed, then you can run the simple linear regression equation. If assumptions are not met, then you need to go for non-linear regression models like a curvilinear regression model or any other regression models. Thank you very much.